So lesson number 6 is interpreting relations using a graphing calculator. So if we take the class example from lesson number 3 that had to do with the car depreciating. Lisa's car that she purchased for $20,000. The value of the car is represented by the formula 20,000 minus 1250t, where v is the value of the car in dollars and t is the age in years. So if we were to graph this using a graphing calculator, first thing that we would need to do is make sure that we clear out any graphs that are in there. And if we type in our 20,000 minus our 1250, we use X. We use this button that's right beside the alpha button. We don't put other letters in, otherwise the calculator's not going to be able to do it. The calculator's programmed that the horizontal axis is always X, vertical axis is always Y, regardless of what these variables are that are given to us. So if we were to try to zoom standard this, so if we did zoom 6, we'd notice I'm scrolling and it stops and I've got a blank screen. It doesn't mean that there's nothing there, it just means that what's there doesn't fit the screen. Because if I look at my table of values, at 0 I'm at $20,000. So that's a pretty big amount. So what I could do to help me out is I could press zoom and then fit, which is 0. Yeah, 0. So if I went zoom 0, now I've got this graph. The graph is showing me where it's crossing the y-axis. Hasn't really shown me where it crosses the x-axis because this is not an axis. The dotted line is not an axis. But what this can do is it can help me try to pinpoint a window setting. So in this graph, what does the vertical axis represent? And what does y represent? The value of the car. What does the horizontal axis represent? The time in years. So with that said, do I need a negative time? No. And am I going to need the value in the negative time? No. Am I going to need a negative value? No. A negative value means I actually owe money for the car. Now, unless I total the car before I pay it off, I shouldn't actually have to owe money at the end. So if I go to my window settings after I do this zoom fit, the calculator's made some adjustment for me. It's got a y min of negative 10. Well, I don't want it to be negative 10. I want to start at 0. My x max, we can leave that at 10 right now if we want, or we can bump it up. We're going to bump it up to 20. And we'll go up by 5s. Just because in that graph, the way that it was showing it hitting that dotted line, which is 7,500. That's what that dotted line was. If I want that dotted line to now go down to 0, I can change it to 0. 32,500, that's too high. When I only need up to 20,000. So maybe I just go up to 22, just so that it's not starting. Oops. And then my scale, I could go up by every 2,000. That would be my tick marks. Now if I press the graph button, now I have a better graph. I can see both of my intercepts. That's what I want to see on my graph. I want to see where it crosses the v-axis, so when the value, when time is 0, and I want to see the t-axis, or the t-intercept. What is the, how much time does it take for the value to hit 0? So now that we've adjusted our window settings, we can sketch the graph. So if I sketch my graph kind of looks something like this. What I will eventually want to do is label these points. And this point, I could label already. We already did the question, but even if I couldn't, I could find out the value of this point how? trace, and then what do I press? 0. And I get 20,000. So I can now label this point right here. So this is my v-axis, and I can label my 20,000. And then I can put in my window settings. So for my x's, we went from 0 to 20, and I think we went up by 5s. My y's, we went from 0 to 22,000, and we went up by 2,000. When I'm looking at your graphs, when you do questions on a quiz, assignment, what I would do is I would look at your window settings and see how they compare to the window settings I would choose. If they're in the ballpark, you're going to be fine. If they seem a little bit off, what I might do is I actually might graph the equation with the given window settings to see, can I see the x and the y intercept, and does the graph take the majority of the screen? Okay, so in this case here, if I had my window settings going from -20, like that, well, I'm only using half the screen, so why would I look at this whole part of the graph unless it was important? I don't need it, so I don't want it in there. I want to be able to see the parts of the graph that matter the most. Okay, question B says calculate the t-intercept of the graph using the calculator. So the t-intercept, that's this one right here. How do I find the t-intercept? 2. I'm finding the 0. So the left bound means I need to be on the left side. So I watch these y values. I can press enter. And then on the right side means I need to be on the right side of the 0, so I need to be in the negatives. So I'm going to watch for this y value to become a negative. Once it's a negative, I can press enter again. I press enter one more time. And what's my 0? 16. So the t-intercept equals 16. What does that mean in terms of the question?
After 16 years, the car is
So after 16 years, value of car is 0. The v-intercept we already did. Okay, we should put in that this was the 0. And the v-intercept is where I did that trace and I let x be equal to 0. So the v-intercept was $20,000. In the context of this question, what does it mean? The vehicle is brand new. Okay, so brand new. Car is worth $20,000. Use the trace feature of the graphing calculator to determine what the car will be worth in 5 years. So trace, 5 years, what's the car worth? $13,750. Question E says, use the intersection feature of the graphing calculator to determine when the car will be worth half the purchase price. So, in terms of the graph, what am I trying to find? Am I trying to find V or T? T, I'm trying to determine how much time it's going to take for it to be equal to half. Where's half? Pardon?
8.
How did you get 8 years?
16.
Nice, that works.
Yeah.
How can I use the graph to do it though? What if you didn't know what the t-intercept was? What if you didn't know that this was 16? How could you find that out?
Find 10%.
What if the equation was different?
Oh, we have to
And
do
go
it
to
differently.
Y to
What you're trying to find is if x equals 10,000. So if x is equal to 10,000, if this is my 10,000 mark, or sorry, not x, y, the v value or the y value is equal to 10,000, what's the x value? That's what you're trying to find, is what is this t value when v is equal to 10,000. So I can't use a trace because I can't input a value in for y. But I can trick the calculator by letting y2 equal 10,000 and find the intersection. So on your screen, you would let y2 equal 10,000. And there's my horizontal line. And I want to find the intersection point between these two graphs. So second, calc, intersect. And then I get my 8 years. So then on my graph, where I would label this, is right here. So that's what it would look like on my graph. The last question asks us about domain and range. What is domain? Say that louder, Tyrone. It's the x values. What is the range or the span, I guess might be a better word to use, of x values that I can have? So what is the span of x values that I can have in this graph?
0 to 16.
0 to 16 years. So instead of putting x for domain, I would use the variable given, which would be t. Now, how can I write this? Can I write this as set notation, interval notation? How would I write this? So can it be anything between 0 to 16 years? Yeah, so I could use interval notation from 0 to 16. If I did set notation, it would be the set of t values such that t is between 0 and 16, and t is a real number. So that's my domain. When I'm looking at my range, which values am I looking at? My y values, which in this case has the variable of v. So what are my possible v values? 0 to 20,000. And could it be anything between 0 and 20,000? Pretty much. Like the only thing that's going to limit me is the fact that I can't really take a penny and divide it into tenths and hundredths, but I could. Same way that I could if I wanted to take the time and divide it into seconds. The likelihood that I would do that is not as great. So I could write from 0 to 20,000. Or in set notation, a set of v values such that v is between 0 and 20,000. And v is... So class example number 2 looks at using the features of a graphing calculator to find the x and the y intercepts of these relations. So if we start off, we clear the equation that's in y1. And then we're going to put the equation for this equation in here. So this right here is a division bar, which means I want to do the top calculation before the bottom. So to show that on my calculator, I use brackets. Open up your set of brackets, and then it would be 5x plus 15, and then close the, oops. Oh, 5 plus 15, and then, there we go. Then I would close the set of brackets. And then that would be divided by 3. So that's how I use the division bar in my calculator. I use brackets. So the best thing to do is always start off with your standard grid. So that's pressing zoom and 6. And then it graphs it. And what I want to check for is, can I see the x and the y intercepts?
Yeah.
If I can see the x and y intercepts, I don't need to do anything further because all I'm doing is finding x and y intercepts. How do I find the y-intercept? How do I find this one? X equals 0. So I can press trace, 0, and enter. And what is y equal to?
5.
So then my y-intercept equals 5. To find my x-intercept, second, calc, and which choice do I use? The 0. So choice number 2. Now left bound means I have to be on the left side of this x-intercept, which means I need to be into the negative y values. That's the left side. I press enter and the arrow appears. Then I need to move to the right side, so I need to watch for when my y values become positive. Once they become positive, I can press enter again. The arrows are pointing each other. I press enter one more time, and then my screen says 0, x equals -3, y equals 0. So my x-intercept would be -3. Okay, so let's look at B. So clear your equation. -x². So the negative button is this button right here. So I talked about it the other day, the difference between the negative button and a subtraction sign. This one, I would have to use the negative button. X, and then I can use my squared. So x² plus x plus 6. I'm already on my standard window setting, so I don't have to go zoom 6. I can press graph. And then I have this upside down shaped U. Do you guys remember what we called this?
Quadratic.
A quadratic. So the shape is called a parabola. The equation is a quadratic equation. So how do I find the y-intercept of this quadratic equation? Trace 0. And the y-intercept is 6. And the y-intercept is 6 because x is equal to 0. These two terms cancel out. 0 plus 0 plus 6. How many x-intercepts do I have? 2. It crosses the axis in 2 places. So I'm going to give you a couple of minutes. I want you to find both of them using that 0 feature. Okay, so what are my x-intercepts for this graph? -2 and 3. Which in this case I could probably even look and see that it's going through. And I could even probably look at my table. And what I'd be looking for is when are the y values 0. So sometimes it works to look at your table because I can see the x equaling 0, I can see the y equaling 0. But if it's not a whole number, then it doesn't work as well. So x-intercepts were -2 and 3. Oh, I have a quick question. Actually, no, I don't. Never mind. Okay, fractions, decimals. If the x or the y-intercept is not an integer, the calculator displays it in decimal form, always in decimal form. The calculator does not do fractions on the graph. So if I wanted to trick or convince the calculator to put this into a fraction for me, this is the procedure I would go through. So the first thing that we need to do is we need to put in a different equation. So our equation that we're going to put in is bracket 2x minus 11 bracket divided by 7. And I think that we're okay with our standard window settings.
Yeah.
Press the graph button. Can I see both the x and the y intercepts? Yes, I can. So let's start with our x value. Let's find the x-intercept. So how do I find the x-intercept again? What do I use to find the x-intercept?
Calc 2.
Second calc and 2, so I find the 0. And what do I get?
5.5.
5.5. So there's 2 ways that I could do this. Both ways involve going to your main screen, which I get by going second quit. So what was that 0 again? 5.5. So I could type 5.5, then press the math button, and there's an arrow that says frac. I press enter, so it says take 5.5 and make it into a fraction. 11 halves. Now, suppose the number wasn't 5.5. Suppose it was 5.1623 repeating. That's a lot to have to remember or to try to put in. Press the X button on your screen and then press enter. What happens? It gives me the number that was just in my graph, and then I would repeat the process. Okay? So go back to your graph. How do I find the y-intercept? X equals 0, so I could go trace 0. And now I get something that I don't want to have to put in the calculator. Negative 1.571429, blah, 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 blah. Quit. Now, this one's a little bit trickier because now I need the calculator to pull up y. So if you notice on your calculator, you've got all these green buttons. Where's the letter y?
1. Go alpha 1.
So alpha 1 and the letter y comes up. Press enter and there's that number. Change it to a frac by going math, enter, enter, and there's my negative 11/7. So it does go through the procedure down below. Find enter in the equation y1, find the y-intercept using the trace, press second quick to exit the graph display, press alpha 1 to access the letter y, press math, enter, enter. And then the decimal value may be verified by dividing the fraction. So if I went negative 11 divided by 7, I would get that negative 1.57, on and on. So I would like you to work on questions 6 and then 7, A, C, and F. Okay, the last part that I want to go through with you looks at determining max and minimum values. So in order to, what you can do is you can use the calculator to determine a maximum point or a minimum point on the graph. In order to have a maximum point or a minimum point on the graph has to change direction at some point in time. So the ones that we're looking at is we're looking at these quadratics, these parabolas. So this right here would be the maximum point. This is as high as the graph is going to go before it turns back and starts going down again. So if we were to enter that into our calculator, this is the equation that we're going to put in. So negative x squared plus 5x plus 14. And then we have window settings that were provided to us. So we press the window button, -5 to 10, going up by 5, so that's what the x scale means. -5 to 30, going up by 5s. And then if I press graph, I get this quadratic. And what I want to know about the quadratic is I want to know about its maximum point. I want to know the maximum point right here. So the way that I do that is I go back to that calculate menu. And it's choice number 4. Not number 3. This is the maximum point. When you press that, you get that left bound, right bound. Left bound means be on the left side of the maximum. And then press enter and an arrow appears. Then it says right bound, so it says get to the right side of that maximum point. Press enter and another arrow appears. We want to make sure the 2 arrows are pointing each other. We press enter again, and it gives me the maximum. Now in this case, it gives me 2.5000013. We're going to count this as a 2.5. So the x-coordinate is at 2.5. The y-coordinate is at 20.25. So if I scroll down, we are at this point right here, and I've got 2.5. This one on this screen was giving me 2.4999978, and then 20.25. I can change that into a fraction, and I can get 81 quarters. Now, this number 7 talks about why the 2.499 and the 2.500. Due to the limitations on the calculator, the x value on the display sometimes varies from calculator to calculator. The answer obtained may depend on the window settings used, the boundaries. It could even have to do with the resolution settings. All the answers, however, should be rounded to the exact answer in this case, which would be 2.5. And I could test that. If I took my calculator and I went trace 2.5 and then went enter, notice how my y value stayed what it was. It stayed that maximum point. Okay? So what you can practice with is question 8A and 9A.